no modo somente escuta.
Buenos días a todos, espero que me vean. Luz, dame solo un feedback que se me escucha, si está todo bien.
Sí, perfecto, bien.
Perfecto, entonces primero quería dar las gracias a los que están presentes a esta hora. Sabemos que la hora no es tan buena para todos, pero hay que arreglar con la gente de todo el mundo, ¿no? Entonces, este es nuestro segundo seminario. Pensamos hacer tópicos muy de investigaciones, entonces a veces son muy específicos. Entonces, y la idea es traer la gente que de verdad tiene interés en estos temas. Tenemos, para que sepan, 209 inscritos hasta ahora de 17 países diferentes. Gracias Portugal por estar presente, porque tenemos un montón de gente de Portugal. Entonces, este es mi agradecimiento personal. Yo quería agradecer también a Horst de Cochlear de Europa, que nos ayudó muchísimo con toda esta organización. Peter Gibson, los ponentes que no voy a hablar antes porque Federico Di Lela lo va a presentar. Y rápidamente hablar de nuestra misión, porque nuestra misión es empoderar a las personas para convivir mejor con los otros, transformar la forma que entienden y tratan su pérdida de audición y la pérdida de sus parientes, pero si no innovamos, no logramos los demás. Entonces, yo siempre digo que la investiga todo el proceso de tratar, de transformar, de empoderar, empieza con la innovación. Entonces, esta es nuestra misión, innovar siempre para ofrecer al mercado una gama de soluciones auditivas que permitan que las personas transformen y se empoderen, ¿sí? Bueno, aquí son los disclaimers siempre. Esto no voy a detenerme porque cada presentación tiene su propia responsabilidad. Cada ponente se responsabiliza por su propia presentación. Y ahora sí, les informo un poquito sobre la traducción. Yo creo que recibieron un correo más o menos 30 minutos antes de la presentación. Van a ver esta pantalla. Tienen que acceder a los links de traducción por otro dispositivo. ¿Y por qué? Porque este dispositivo que están mirando el seminario estará siempre en inglés o español, ¿sí? Y para acceder a la traducción de inglés a español y de inglés a portugués, tienen que se conectar por un otro dispositivo donde van a mirar siempre esta pantalla, ¿sí? Entonces acá tienen las instrucciones que deben haber recibido por correo de cómo se conectan por otro dispositivo a el sistema de traducción. La otra parte es que cualquier duda que tengan, cualquier pregunta que tengan los ponentes, que pongan en la parte que está preguntas, questions, depende de cada idioma, va a estar de una manera. Entonces pongan acá y al final de todas las presentaciones vamos a contestar, ¿sí? Y para que no quede esta pantalla, también pueden hacer clic en esta flecha roja y esto se queda pequeñito al lado, ¿sí? Mira, las instrucciones que recibieron de traducciones están acá. Entonces, para los hablantes de español que van a escuchar, necesitan la traducción de inglés a español, tienen sus instrucciones, y si van a llamar al teléfono tienen que poner este número con el hash. Y para los de inglés, si necesitan escuchar alguna cosa en español, que va a ser casi nada, porque todo va a estar en inglés, también el mismo número, porque es la misma traducción. Y para los de Portugal, vou falar um pouquinho em português agora, para ter acesso à tradução do inglês para o português, se tiver no Brasil, pode ligar para um desses números e dizer, selecionar esse código e o hash, vocês já vão conseguir escutar a pessoa falando em português ou diretamente no link que vocês receberam. Bueno, volviendo a español, yo hice la apertura, ¿no? Yo soy gerente de investigación para Cochlear América Latina, entonces siempre queremos estimular todo tipo de investigación y discutir siempre tópicos muy avanzados. Y voy a pasar la palabra ahora al doctor Federico Di Lela, que es nuestro consultor y siempre va a seguir con nosotros en estos seminarios. Después vamos a tener la palabra de Peter Gibson, doctor Scholler y por fin doctora Arlier, que va a explicar un poquito de sus trabajos más específicos. Por fin tenemos la parte de preguntas y después yo hago un cierre general. ¿Sí? Federico, te paso la palabra. Federico, si quieres encender su cámara, es jefe interino del servicio de otorrino del Hospital Italiano de Buenos Aires, es miembro de la CORLAS, que es el Colegium Otorrinolaringológico, que es una entidad mundial, secretario del exterior de la FASO y consultor de Cochlear. Fede, no sé si ya me escuchas, si ya me ves, yo voy a cerrar mi pantalla y te paso la palabra.
Bueno, muchas gracias, Bianca. Un agradecimiento para...
Te interrumpo un momento, solo para dar el aviso de los videos. Tenemos algunos videos durante la presentación y estos videos sufren un delay para que se cambien entre una presentación y un video. Entonces, los delays son este tempito entre cambiar pantallas para pasar el video, para que garantizamos la calidad de que lo vean los videos, siempre va a pasar. Entonces, solo para que entiendan que tenemos un delay entre los pasajes de video. Perdón, Fede, puede seguir, doctor, con su presentación y ya me voy.
Al contrario, Bianca, agradezco. Bueno, agradezco a toda la audiencia y a Cochlear la posibilidad de colaborar desde el Hospital Italiano con esta presentación y con esta idea de estos simposios que venimos realizando aproximadamente cada 3 meses. Y la idea es justamente, como bien dijiste, Bianca, en la introducción, es plasmar un poco avances en el campo de la otología y puntualmente de la implantología en cuanto a tecnología, técnicas quirúrgicas, mediciones objetivas y un poco una mirada al futuro. La verdad que nos llevó un poco contactar y tratar de tener en mente cuáles serían aquellas personas representativas a nivel mundial que podrían colaborar con nuestra línea de seminarios planteados, y en conjunto con el profesor Carlos Bocio, que aquí me acompaña, quien es jefe de la sección de implantes cocleares de nuestro hospital, hemos puesto un poco en contacto y con Cochlear a distinguidos profesionales que hoy disertarán sobre los tópicos que pronto veremos. Así que un poco aquí están los objetivos. Pásame, Bianca, por favor, a la siguiente. Y vamos a presentar en primer lugar a Peter Gibson. Peter Gibson es una gran persona, a quien tuve el gusto de conocer hace varios años ya en la compañía. Es vicepresidente de investigación y desarrollo en cirugía, electrodos y enlace en campo de Cochlear Australia, y miembro del equipo de implantes cocleares y cirugía de Cochlear específicamente. Peter ha estado involucrado desde hace muchísimos años en la compañía, en el desarrollo de avances relacionados a técnicas de fabricación de electrodos, como así también mejoras en el campo de la implementación desde el punto de vista de técnicas quirúrgicas. Le hemos pedido a Peter en este caso, y dada la diferencia horaria que existe con Australia, allá son alrededor de la 1 de la mañana, de la madrugada, que nos arme una presentación, que es la que vamos a ver a continuación, y es un gusto contar con la participación de Peter, quien además ha servido de referencia para la organización de este simposio. Por favor, Bianca, si podemos empezar entonces con Peter, yo apago mi cámara y quedo luego para la siguiente presentación.
Sí, en este momento tenemos este delay para pasar la...
Hola a todos, soy Peter Gibson, ingeniero de cochlea desde hace más de 20 años. Es un placer estar hoy con ustedes. Como solo tengo 15 minutos, debo cambiar al inglés. I wish to thank Dr. Dilella for the opportunity to speak today on the topic, a look to the surgery suite of the future. Why this topic? CI surgery is routine and safe surgery. However, there is an opportunity to innovate and improve. So today I'd like to share thoughts on a long-term vision. This is based on what we can learn from other fields and the potential to improve specific points of cochlear implant surgery. Please note that this conference is a forum for education and information. Many of the products and concepts presented today are not approved. First, I'll talk to robotic-assisted surgery. This is an interesting place to start, and then I'll broaden to the wider surgical suite. Then we'll take a design perspective, and finally summarize. Robotic-assisted surgery. Many of you will be aware of all of the examples of robotic surgery that exist today, such as transoral robotic surgery, bronchoscopy, and interventional radiology. Now, I picked these because they all involve insertion of a long, flexible carrier into a difficult space, a bit like a cochlear implant insertion. They can all be done with a manual insertion. However, there are benefits to a robotic insertion. And here's a summary. Minimally invasive, access to tight locations, stable and precise targeting and control, and integration of vision with navigation, and some others you see there. And you can imagine that some of these could be applied to cochlear implant surgery with some benefit. So now let's look at some surgery trends. First, a global view. It's estimated that surgical robots will double in the 5 years from 2021 to 2026. And then a local view. In this study, they looked at changes in procedure after hospitals began performing robotic surgery for the first 4 years. And they saw that robotic surgeries increased 15%, whilst the other forms, open and laparoscopic, reduced. And so robotic surgery is trending up. There is some controversy, however. This is an interesting recent multi-center, blinded randomized controlled trial, quite powerful, with 124 patients, where they compared robotic ventral hernia repair with laparoscopic ventral hernia repair. And their measure was the number of days in hospital. And in this study, they found that robotic repair did not decrease the length of stay, it nearly doubled the operating room time, and it significantly increased the cost of healthcare. So this is an important lesson that just simply introducing robotic surgery does not necessarily bring a benefit, nor may be cost effective. And so we need to think carefully. So what does the CI surgical suite of the future look like? Could it be this, an exoscope with a camera mounted on a robotic arm and displayed on a screen? This, more navigated surgery with the robot as well. Or a smaller robot mounted to the operating table, holding the electrode for insertion or other instruments. Or the Da Vinci system. Now you may be surprised to hear that the Da Vinci system has been studied in a cadaver study and successfully performed these steps. And we've shown that you can insert an electrode with the Da Vinci system as well. However, I would question whether a machine of this cost and complexity is a good application to these steps. So let's now turn to a design perspective. And for me, this is about asking the right questions. The first being, what are the needs for our particular surgery? What are the potential solutions? Third, which of those options best address the needs? And fourth, what are the health economic considerations? Now, this is a big field. I'll only be able to really attend to the first two in some detail, and I'll make a few comments on the others. Turning to the needs. Now, our greatest need in our field is to bring this intervention to more people. As it says, hearing loss is prevalent and undertreated, and you've seen these statistics before. But what can a surgical suite do about this? Well, we know that getting treated is an obstacle race. There are many reasons why people do not get an implant. 3 of those are fear of surgery, the risk to lose residual hearing, and variable outcomes. And we believe that technology can play a role to reduce these hurdles. And the surgical suite of the future can be part of that solution. Now, I'd like to set some context first and look at how we can improve on outcomes and consistency of outcomes. And in this slide, I'd just like to present some recent studies on the slim modiolar electrode and the improvement in hearing outcomes. In this nice paper by Holder, they compared matched groups, straight and perimodiolar electrodes, and they saw a significant CNC word score benefit in the CI532 group. And this is due to the focus stimulation. And another recent study by Hutink showing that independent positive variable of the pre-curved electrode was 11.8%. And these, of course, are for well-placed perimodiolar electrodes, as you see in this example here. And I'd also like to introduce this background to the slim modiolar and hearing preservation as a context. This is a nice paper by Nassiri showing some great results in hearing preservation of the slim modiolar electrode, comparing the preoperative low frequency pure tone average with the 6-month result. And you can see many of these recipients stayed within a very tight band of their original hearing performance. Though there's an opportunity still to optimize the perimodiolar position. We do see electrodes being inserted in a really nice position, as we see here, close to the modiolus with narrow spread of excitation. However, it is possible, and we have seen some cases where the electrode is inserted further than necessary, which moves it away from the modiolus, widens the spread of excitation, and potentially impacts on the basilar membrane out near the lateral wall, and thus potentially losing some of the potential for hearing preservation. Now, there is a simple solution today. If an electrode is over-inserted, then a simple pullback technique can bring it back onto the modiolus, as shown in this publication by Ryman. However, it would be better if this wasn't necessary. Particularly, we'd rather not have the electrode move out towards the lateral wall. So there is an opportunity to optimize this situation. So in summary, I've picked one key need, and that is to improve the consistency and predictability of surgical and hearing outcomes by consistently placing the electrode close to the modiolus while dependably preserving structures and function. Now, some of the benefits that we saw before from robotics could be applied to improve on this situation: the stable, precise targeting, integration vision with navigation, and measurement accuracy. So now let's look to some potential solutions. I'll share 3 examples. First of all, preoperative planning. Today, of course, surgeons receive their imaging ahead of the surgery and they make a plan. In the future, surgeons will receive 3D dimensioned anatomical models that will allow them to look at the relationship between all of the anatomical structures. This will allow them to personalize their insertion so that they achieve an optimal placement for each individual anatomy. And a 3D model is also valuable for complex cases. Now, the first case here is described nicely in this paper by Vanderbilt. They've received a scan, segmented it, and created a model. The surgeon can look at the model on a 3D viewer, spin it around, understand the anatomy. And then they can look to put a electrode array over the top of the model and determine the optimal insertion depth for that electrode array to achieve a perimodiolar placement. And further, they can look to select the optimized entry vector. In this surgeon's view of the model, you can see the facial nerve, chorda tympani, and the access to the cochlea. And the surgeon can understand the access that they will have, how they can widen that to the best possible way, and select the best approach, whether it's round window, extended round window, or cochleostomy. A second example is augmented reality. I'll show this example first, and then I'll come back to cochlear implants. This is a spinal case. The surgeon, in this instance, wears a VR-type headset, the goggles here, and they can see the surgical field as normal. And I picked this particular case because it's got a tight surgical field, similar to ours, and it requires quite some precision. Now, with the augmented reality, they can project onto the back of the goggles the underlying structures of the spine here and confirm that they are in the right location. And they can even add some further direction, like these splines that you see here, or for cochlear implantation, perhaps a trajectory or an orientation of the cochlea. So With augmented reality, we have the possibility for some guidance, and that can improve the potential to make the posterior tympanotomy the widest access possible, which will help with their insertion trajectory, and indeed to provide some guidance on the trajectory itself. So our goals here are to achieve an optimal insertion dynamic and a precise and consistent placement of the electrode. And the third example is robotic assisted insertion. Some of you will be aware of some of the robots in research at the moment. I picked one that you may not be familiar with. This is by Johns Hopkins, and it's actually a robot designed for the eye, but you can imagine its application to the ear. In this robot, the surgeon continues to hold the surgical tools. The robot, however, is a steadying influence, and it can control the surgeon's tremor, can provide some boundaries on speed of movement and the distance of movement. Over here, you can see a bit more detail of their robotic technique. Here's the eye, here's the surgical instrument, and the robot actually holds the tool as well as the surgeon holding the tool. So the robot provides some steadying guidance. Now, for cochlear implant surgery, this would allow manual control. We could add navigation, and as I've said, some guidance, and could be bounded in its positions so that the tool doesn't move to unacceptable positions. And in summary, it can achieve a slow tremorless insertion dynamic, which is important for preserving structures and hearing. So I've introduced 3 examples in some detail, and they're in this table here. I'll just mention quickly a few more, and the table, just to introduce it, has an objective or a process, the present state, future technologies, and a target benefit. So I've talked to these 2. The third one is visualization. People have an optical microscope today, and in the future, it's optical or digital or combination, microscope or exoscope, including augmented reality and navigation possibilities. And the benefit of all this technology is it can provide the image plus data and guidance all at once. And the target benefit that we're looking for here is an optimal insertion dynamic and a precise, consistent placement of the electrode. Next is intraoperative feedback. Today, surgeons have visual and tactile feedback, and we're hearing about ECochG today. In the future, there'll be multiple electrophysiological measures, and they will be important for improving our potential to preserve hearing. And then another one to introduce is surgical support. Today, a voice and video call. In the future, a cloud-based 3D video with augmented reality possibilities. And this can be valuable for complex cases. And finally, data capture. Today, paper and recording. In the future, full digital connectivity between all the important instruments. And this will improve our measurements, which can be applied to improving outcomes and efficiency. And if we take the right data, many opportunities to apply artificial intelligence to optimize our surgery. So I'd like now to just summarize. We've had a look at the surgery suite of the future, and we've seen that innovation is happening across the surgical landscape, and we can learn from that. Evolving technologies do have the potential to improve cochlear implant surgery. However, to get the benefits, we must ask and answer the right questions. And I posed these questions before. What are our needs for our particular surgery? And we looked at 1, improving the electroneural interface. Second, what are the potential solutions? There will be many options and opportunities to be researched and evaluated. Which options best address the needs? Well, this depends. The devil will be in the detail. And finally, what are the health economic considerations? And this will require careful selection, objective study, and scrutiny. I'd like to thank you for your attention. I hope that was informative and interesting, and I wish you well in the rest of the symposium. Thank you.
Hola, bueno, tenemos que agradecer a Peter Gibson. Paso la palabra ahora a Federico Vilela de nuevo para...
Bueno, muchas gracias. Gracias, Bianca. Y bueno, un agradecimiento especial para la disertación de Peter, que sin embargo siempre es fantástico, pero sobre todo en esta presentación nos muestra un panorama realmente muy interesante y ya discutiremos algunas cositas seguramente al final de las charlas. Es un gusto ahora y un agradecimiento especial también para el profesor Patrick Schuller, quien es médico otorrinolaringólogo de Alemania, la Universidad de Ulm, examinador de la Junta de Otorrinolaringología de Cirugía de Cabeza y Cuello y miembro de la Sociedad Alemana de Terapia Inmune y Dirigida de Otorrinolaringología, de Cirugía de Cabeza y Cuello y de Cirugía de Base de Cráneo y de Cirugía asistida por computadora y robótica. Patrick, realmente es un gran gusto, un agradecimiento especial el habernos conocido con motivo de haberte convocado a este simposio y estamos ansiosos de escucharte y disfrutar de tus comentarios. Muchas gracias y bienvenida.
Dear Dr. Dilila, thank you very much for the very nice introduction, and dear Mrs. Cagnacci, thank you very much for the perfect organization of the meeting. I hope you can see my interface in a minute.
Yes, perfect.
Just have to make it a bit louder, just to make sure that I hear you. Is it possible to see my screen?
Yes, we can see. It's just to put in presentation. Perfect. We can see in presentation mode. Perfect.
And I can start now. Okay.
Yeah.
Thank you. Thank you very much for the introduction and for inviting me for this very interesting seminar. I'm very happy to talk to you about our experience with the application of the robotic scope in cochlear implant surgery here at our University Hospital in Ulm in Germany. For the introduction, I want to start with the following problem. In the standard microscopic surgery, when we do any kind of surgery with a microscope, we have the problem that the body position has to be adjusted to the microscope. And this can end up in a very unrelaxed and uncomfortable position for the surgeon. And especially if the surgery takes several hours, then this can be very big problem for the surgeon. And at the same time, when we use a standard microscope, the instruments have to be returned to the scrub nurse every time we want to do any changes to the microscope in terms of focus or position of the microscope. And so every time we do this, this is a problem because the workflow is interrupted, and this can be very time consuming. Imagine every time you focus and you change the position of the microscope, you hand back the instruments to the scrub nurse. And this is, of course, not ideal, but of course, somehow we get used to it. And so today I want to introduce the robotic scope. This is this machine, which is produced by the BHS company, which is located in Austria. And this is a video microscope with a stereo vision. So in this box here in the front, there's two cameras which allow for stereo vision. And then here is the stand of the microscope, and you can see the external screen for viewers and the scrub nurse to follow the surgery. And the surgeon himself, he has a head-mounted display on his head. And then the eyepieces, as you can see here in the experimental setup, the eyepieces produce the vision of the microscopic field into your eyes. And this we were able to try in an experimental setting on the first place. And here you can see the special thing with the microscope, with the robotic scope, is that you can open up a menu in your view of field with a foot pedal. So when you press on this foot pedal below here under the table, then you open up here a complete menu for which you can choose different points from, and you maneuver in the menu by moving your head. So when you open up the menu by the foot pedal, and then in the menu you maneuver with moving your head. And then there's different options which you can choose in this menu, and I want to go through them step by step together with you. For example, in the inner ring of the menu, you can choose to zoom, and then this means that you can get a closer view of your operating field. You can choose free view, which allows you to move the microscopic view to the left, to the right, to the up and down. Then in the next point, you can focus and change the focus of your view in the microscopic field. And the last point in the inner ring is the orbit view. And this is something special. That's a robotic feature of the robotic scope, which I want to introduce in the next slide to you. So when you choose orbit view, you can get the following feature. This is a picture of the open mastoid and the posterior tympanocopy, as you can see here. And the cochlear electrode is inserted in the round window. And the robotic scope is placed above this field and looks right into this mastoid. And in what you can do as a surgeon, you open up the menu, choose orbit view, and this leads to the fact that the robotic scope defines a fixed point in this double cone, as you can see here. And then the microscope can move around these double cones and can show you different angles into this in the operating field. And when you choose this, and by moving your head, then you can get different angles, and you always see the same point in the surgical view, but from different angles. As you can see here, when you move a little bit up, then you look more from above, and then from when you move down, you can see more into from below into the surgical field. The same is from the left and the right, and this happens automatically when you move your head. Next, when you choose magnification, you can see how you can get a closer look into your operating field. Again, you have the mastoid with the posterior tympanotomy, and then the round window in the far away. Then when you get closer, you see how it opens up, and here is a very close view of the round window with the open membrane. And this is preclinical. This is in a body donor mastoid, of course. And then we performed in the body donor, we performed the surgical procedure by inserting the cochlear implant electrode. And you can see here again, this is the step-by-step. We open up the mastoid, perform the posterior tympanotomy, and define the round window. And then we take away the edge of the round window. As you can see here, open up the membrane in the here on the lower left side, and on the right side, the electrode is introduced in the round window. This is performed by using the robotic scope. Then I would come back to the menu. Again, when we press the foot pedal, then you open up the menu. And now I would like to go through the points of the external ring with you. And there you can choose to lift up the head-mounted display. This means that the eyepieces of the head-mounted display lift up. And then you can take up contact with other persons in your room, because you have to imagine when you are the surgeon, you only see the operating field and nothing else, because you have the eyepieces in front of your eyes. And if you want to look on the patient, or look at something in the room, or take up contact with the scrub nurse, you are able to lift up the eyepieces of the head-mounted display without touching anything. This is all completely electronic. Then you can tell the robotic scope to store any position during surgery, and then this enables you to come back to the same position again after a while. So if there's an interesting point of anatomic position, you can always go back to this point by letting the robotic scope know. Then you have a media tool where you can transfer pictures and videos to an USB flash drive, for example. Then you can choose the light intensity to make the field more lighter or darker. Then the imaging mode enables you to take pictures of the surgical field. And then you can choose to change the working distance, where you can tell the microscope to get closer to the surgical field or get further away, depending on what's more comfortable for you. All these experiments you can read in the publication, which we have recently published in the International Journal of Medical Robotics and Computer-Assisted Surgery. And also we have a homepage of our robotic surgery group in our ENT department at the University of Ulm, where you can read about this project, which we have with the robotic scope, or other projects which we are performing in this working group. This is a picture of the setup in the clinic, because after performing the preclinical experiments, we decided to perform a cochlear implant surgery in a patient using the robotic scope. This is my patient, my colleague, Ricarda Riepel, who performed the surgery. The patient is lying here. The anesthetist is hidden behind the corner here. Here's the scrub nurse, and this is the robotic scope with the external screen for other people to look at. And then this is how the setup is. Of course, the robotic scope is covered with a sterile cover. This is a picture during surgery. Again, the mastoid is opened on the left side. This is taken during the posterior tympanotomy, which enables us to look into the middle ear, as you all know. And the quality of the picture is very nice. I can tell you, the pictures and the videos as well. So you can, it's very detailed, and it's nicely to perform the surgery. Here's another picture I can show you during surgery again, and here you see one problem which we encountered during surgery, because this is the box where the two cameras are in from the robotic scope, and in this version of the robotic scope there was interference between the camera and the head-mounted display of the surgeon, as you can see here, because of course you need a special angle in to be able to look at the inner ear, middle ear, to introduce the electrode, and this was only possible in this position, and so the camera took the place where normally the head of the surgeon is placed. But I can assure you the company BHS in Austria, they have in the meantime, they have worked around solutions which are able to prevent this interception between the camera and the head-mounted display. In detail, there's a mirror which can be just fixed to the camera, which with a 45-degree angle, and that means that the camera can actually come from above, and you can still see right into the middle ear without having the camera in front of the surgeon's head. Now I would like to start the first video where you can get an impression how it works during surgery.
Tenemos un delay, Luz ya va a ver el video. Dr. Scholler, we can hear you. I think that is because the video. Yes, now we can't stop Dr. Scholler 1 minute because now talk with us.
Thank you. Now I got the screen back.
So yes, so let me speak in Spanish. Cuando el video se presenta para garantizar la calidad de video, no se escucha el ponente. Dr. Schuller, when the video is showing, we can't hear you, so now you can explain the video, okay?
So I can explain now. I said that it's this wasn't a video of the external setup in the OR, in the operating room, because this is more informative for you, because you all know how cochlear implant surgery is performed, so it's not helpful to show you the video of the surgical procedure, but this is the view of the external video, and you could see how the setup was and how people can follow the surgical procedure on the external screen of the robotic scope. Then in conclusion, we got the impression that cochlear implantation is very well feasible with the robotic scope, and we have very good visualization, including robotic features like the orbit view, as I've shown you, or storing anatomic locations in the microscope. Then we have excellent company support, and as I've described for you, in the version of the robotic scope which we had used in our OR, we had interference between the camera and the headset, and this is something which has been solved by the company by now. You have to be aware of the fact that you have limited contact with the surrounding persons around you in the OR, because your eyes are completely covered by the eyepieces. So it's not that you can look at the scrub nurse or look at any colleagues who are around you or at the patient, because you only see the operating field when you have the head-mounted display on your head. And the price of the system is above 150,000 euro plus a service contract. Now I want to show you an outlook, because this is about dual view. This shows that in some surgeries, not especially for cochlear implant surgery, but for other surgical procedures as well, that it may be helpful that you have a second operator or an assistant who can see the same field as you. And so this is something which will be introduced shortly, by the company that actually two surgeons can have a head-mounted display at the same time. And there I would like to show you the second video, which is a video from the company.
Estamos poniendo el video.
Okay, thank you very much. I thought this video would be interesting because it showed you how the eyepieces are lifted up automatically by the system when you choose in the menu to lift up the eyepieces. And that's, in my opinion, this is very important to get into contact with your surrounding field in the OR. And then this is a video which I would like to show you again. Hopefully it works. It shows you the different features again while using it, while using the menu. And I hope you can see it. And this is how you can choose the focus. You can change the focus by moving your head up and down when you choose this point. This is the zoom of the zoom feature. And all this movement in the menu you do by moving your head. And you can choose the light intensity to make it lighter or darker. And then lastly, this is orbit view. You can see how it moves around this fixed point, and you can always focus on the same point in your operating field. Okay, I hope this video worked for you. And at last, I would like to thank Cochlear for supporting our experiments here in Germany and for inviting me to the seminar. I would very much like to thank the company BHS from Austria for providing the robotic scope system in our clinic to perform the preclinical experiments and also the clinical cases. And of course, I would like to thank my colleagues without whom these experiments would not be possible. Thank you very much for your attention.
Thank you, Dr. Scholler. It was a pleasure for us to have you with us. So now I pass the word to Dr. Delela.
Bueno, muchas gracias, Patrick, por la excelente presentación y lo alucinante de ver estas nuevas tecnologías aplicadas en el ámbito incluso de nuestra especialidad ya, lo cual es muy interesante. Haremos algunos comentarios seguramente y me vienen a la idea algunas preguntas y ya tenemos incluso algunas preguntas de la audiencia e incluso de algunos presentadores para hacerte al final de la presentación. Vamos a dar lugar ahora a la última, pero no menos importante, de las presentaciones del día de hoy, profesora doctora Diana Harvard, quien es consultora del Departamento de Otología y Cirugía de Cabeza y Cuello del Hospital Universitario de Essen, de la Universidad de Duisburg-Essen, en Alemania, médica jefa de la Unidad de Otología, Neurootología y Audiología Clínica, y jefa de la sección de implantes cocleares y de oído medio. Es un gusto, Diana, haberte contactado, que hayas aceptado estar aquí la participación y de igual modo, repito, estamos muy ansiosos de estar atentos a tu próxima presentación. Muchas gracias.
Buenos dias, señores y señores. Good afternoon, everybody. I'll try to share my screen right at the moment. Thank you very much for the invitation. I'm really honored to be here with you, and well, I hope I will be able to introduce here my presentation. So what is my task? My task today is to talk about a digital real-time visualization of electrocochleography during cochlear implantation.
1 minute, because we can't see your screen.
Okay.
Luz,
You might be able to do
no.
it.
Perfect.
You can see it?
Yes.
Yes.
Yes. Thank you.
Okay, there we go. So this is a feasibility study of electrocochleography, and well, I have to thank my colleagues, and it was a cooperation product from Cochlear company and also ARI in Munich Medical Surgery Imaging. And now we go on to the next. I do have problems. So now there we go. This is our department. This is the whole University Hospital of Essen, and this is the Department of Otorhinolaryngology, which you can see here. This is our new surgical center and outpatient care. And well, Peter Gibson talked about it. Right now, our surgical setting is fully digitalized. We don't have any paper anymore, so it's all electronic and digital, and well, we got used to that. So what is our real problem? I will have to talk about the electrocochleography and visualization for the surgeon. Right now, it is like we have pre-operative information, imaging, CT scan, MRI, audiometric diagnostics like subjective and objective audiometry. And we do have our intraoperative setting, which means there's a surgeon and a microscope, which is usually analog. And we have our medical device, which means the cochlear implant. Usually everything which controls the success of the implantation is done after insertion of the electrode, which means we have intraoperative measurements by the audiologist, which is impedance measurement, transimpedance measurement, sometimes stapedial reflexes, neuronal response telemetry like electrical compound action potentials, and the spread of excitation. And then we have our intraoperative imaging, which is also done after insertion of the electrode. So what would be, we would be interested.
I'm sorry to interrupt. Do you could you open your camera, because we can't see you? It's just to.
Oh, I'm sorry.
So sorry. No, I'm sorry to interrupt you.
There we go. That's
perfect.
better now.
Thank you. Yes,
Okay.
it's perfect.
So what's the problem right now? We have I have some videos here. We have the aim of preservation of anatomical structures and residual hearing, but right at the moment the surgeon is incapable of watching the insertion process intracochlear. So what we would wish, everybody of us wishes this, to watch what's going on and where the electrode is going inside of the cochlear. Well, actually we can't do that. So we can use electrocochleography, which usually is done like we can see in the picture on the right-hand side. You have your probe, which is going inside of the ear canal, and well, here you see the facial monitoring, and there's the audiologist. The definition of electrocochleography for everybody, just for repetition. Initially, this means that we are measuring intracochlear potentials, which are produced as an answer to acoustic stimuli, and we can differentiate the cochlear microphonics, which correlate to triggering stimulus and measurement of the Hertha response. And we have the somatic potentials synchronous to the stimulus, resembling the nonlinear vibration of the basilar membrane. And we do have the somatic action potentials, which are stimulus dependent and corresponding to the wave 1 of the brainstem evoked response audiometry. So this is how this is usually measured, and our idea was, well, if we use the intraoperative electrocochleography monitoring as a kind of navigation tool for the preservation of residual hearing, can we translate this to the surgeon? So usually the audiologist observes the electrocochleography on his monitor or her monitor and reports this to the surgeon. And this kind of report means the surgeon sees and controls the electrode movement via the round window, while the audiologist says, well, stop, go on, the signal is dropping down or it's rising, and always you do have a deficit of information and a time delay by the verbal delivery of this information, and this always leads to misunderstandings. So possible solution might be the visualization of all information to everybody. So here we come with a digital microscope, and we do have the possibility, well, you have your picture, which you can see on the screen. This is the difference to the analog microscope you see on a digital screen, and it's also only mimicry that you have a binocular, but you can also have pre-operative video data, you have CT scans, you can have the navigation tool, and if you can put in here the external video sources, you can also put in electrocardiography screening. This was the idea. So the technical setup means you have a video signal which is transferred from the HDMI output of the electrocardiography laptop, and this goes via a converter as HDI SDI signal into the fully digitalized microscope. And then you have your picture signal of the Cochlear research platform, and this appears now on your digital display. So the surgeon is able to control and change the display via handles. How does that work? Here you see the complete setup. This is the microscope, and there you have the screen for everybody in the OR, which means maybe CT scan or navigation. And here you have the electrocardiography, and this is the same you can see here on the screen as a surgeon. So here you can see what's happening in the OR while inserting the electrode. Here you can see it somehow better. I don't know why this is black, I'm sorry, I have no idea, but you can see it here. You insert the electrode, and you can here see the signals, which are the response of the electrocardiography, and this is about, well, 3 signals per second, and if the signal drops, you can stop and then you go on again or pull back and your electrode and go forward. So the aim is that you can well, to hold this line in one section to get your signals. So you really see as a surgeon what you're doing, and this is an incredible well, gain of information.
Is it okay, doctor?
Yeah, it's okay. I don't know why now there is also another tone, but I will leave it like that. Can you hear what is going on here? So you see the signals of one patient after 1 year, after 6 weeks, after 3 months, and after 1 year. And here we have a significant prolongation of insertion time. We compared without seeing what we are doing to we are seeing what we are doing, and well, it lasts about 150 seconds if you see what you're doing and control via the signals with your own visualization. So here you can see the bone conduction threshold at 250 and 500 Hertz. In comparison with a picture-in-picture mode, and we could control in 10 patients the whole residual hearing by seeing what we are really doing. This was an enormous gain of information, and I won't miss it anymore. So the technical connection without problems. We do have direct information of visualization, which leads to a significant gain of information from the surgeon's point of view. and we have a low insertion velocity due to the visual feedback, which seems to provide a better hearing preservation. The position of the ear canal probe is really important for quality of measurement, and the results of the amplitude growth function are slightly better than the bone conduction thresholds. So thank you very much for your attention, and I think this is another piece of information we can insert in the whole product of computer and robot assisted surgery. And I hope you enjoyed this presentation, and I'm curious on your questions. Thank you very much.
Thank you.
Bueno, muchas gracias, Diana, por la presentación. Excelente y sorprendente lo que permite el registro eléctrico en este caso y el feedback para el perfeccionamiento y mejora de la cirugía, sumado a la tecnología en cuanto a cómo mostrar eso de una manera dinámica para el cirujano en tiempo real, y cómo la tecnología no solo basta con tenerla en el quirófano y a disposición, sino ponerla en simultáneo con ciertos pasos de la cirugía, y creo que eso fue muy captado desde tu presentación y con la idea del trabajo de ustedes. Así que muchas gracias. Como le bien estamos acá ansiosamente Bianca y de preguntas.
En inglés, no, te iba a pedir que repita en inglés because the doctor don't have access to translate in English.
Okay. Thank you, Diana. I would like just to thank you for your presentation. We really appreciate that. And well, it is interesting to see how technology in the OR is really good, but not only to have technology in the OR, but the concept is to put in simultaneously the technology during certain steps during the surgery, just to get better outcomes in our surgery. So it is that's what I get for your presentation, the idea to put all the things together at the same time, trying to get the information for the benefit of the patient. So the most important point, in my opinion, during the CI surgery is the time when we are introducing the electrode, inserting the electrode, or like around the basal chain of the cochlea. So, and this time is completely blinded for the surgeon. So we really don't know what's going on inside the cochlea during the insertion, which is critical for the health of the cochlea and for sure for the post-op benefit for the patient. So the interesting thing is now you show in your preliminary reports how interesting and what the influence to have information of this blinded process during the surgery. So
that's
as
right.
much information. So we delay the insertion, we get more information about the benefit or what damage are we going during the insertion. So that's right. The interesting thing.
You have really the possibility to influence it yourself. You can slow down or go forward, and you see what you're doing. That's much more information than we had before. You're not. We know something about insertion angles, and we know, well, you have to do it smoothly, but you never know what you're doing. You're kind of blinded, and with this procedure, you have some more information. And once you have this information, you know that you can get it. You will never miss it.
Yeah, definitely. Thank you so much. So we move next to the question section. So I will switch to Spanish now. So si hay alguna pregunta, por favor, sería interesante. Tenemos algunas preguntas ya en el auditorio y un poco alguna pregunta que generó incluso Diana para Patrick en el sentido del Robotic Scope y qué información o cómo ven la utilización del Robotic Scope en el hecho de poder visualizar pequeños recesos con poca iluminación dentro de cavidades del oído medio, por ejemplo, a través de timpanotomía o en la región del seno timpánico o en la región hipotimpánica. Si por favor, Patrick, estás allí y quieres colaborarnos con responder esto, Diana, por favor, será un gusto.
Sí, pero Federico, hay que traducir al doctor Scholler la pregunta de doctora.
Okay. So Patrick, we have some questions from the audience. The first one is from your colleague Diana. So she wants to ask you, what about enlightening situation in deeper files of the tympanic cavity, for example, using your Robotic Scope, and what your opinion about that? So could you please explain a little bit more about that?
I understood most of it. It's about the lightning situation in the deeper parts of the middle ear. I found this was not a problem. You are able to adjust the lightning situation by choosing the right point in the menu. And what was very interesting is that the company chose to give a very strong zoom function to the robotic scope. So it's actually too much. You can zoom much more into the surgical field than it's necessary for the OR, for the surgical procedure. As maybe you remember my screen where I showed the zooming function, and it's way too big. Like we never used the full the capacity of the zooming function. And the lightning situation was not a problem with this, no.
I would be curious to try it. I come over to Owen.
But I have to admit, like we did not perform 10 or 20 cases, and in the beginning there were some lessons which we encountered, and the one problem was mostly the interference between the camera and the head of the surgeon. But I'm very curious to try it again now with a new solution. It's a very.
That answers my second question. I asked if it's a routine procedure right now.
No, it's not a routine procedure yet.
Okay.
Hopefully we can get there, and then we can even introduce ECochG to our cochlear implant surgeries.
That should be the aim, the goal.
You should
to use every
experience together.
For certain.
Thank you for the question.
No sé si hay alguna otra pregunta, Bianca. Yo tengo aquí en disponibilidad esta por ahora, pero no sé si.
Sí, hay una de Dr. Arlier, but I'm not sure if the Dr. Scheller answered.
Yeah, he already answered that. Yeah. No sé si hay traducción del inglés para el español, Bianca. ¿Quiere que traduzca algo?
Sí, no, están todos con traducción, está todo perfecto.
El problema es del español al inglés, perfecto. Okay. So, interesante, quería hacer algunos comentarios al respecto de las presentaciones. Bueno, la primera en relación a lo de Peter Gibson, creo que es interesante una mirada integrada de cuáles son los distintos pasos y cómo verdaderamente es nuestra tarea también, como especialista en este campo, estar atento a los avances tecnológicos, y es evidente que al estar incluso en el campo del implante coclear, poniendo un dispositivo electrónico en contacto con el ser humano, es evidente que la tecnología no la podemos dejar aparte, y claramente los beneficios del avance tecnológico están empezando a ocupar un rol cada vez más importante, y va a ser una tarea nuestra también estar atentos a esos avances y tratar de unir y servir de link entre los avances tecnológicos y cómo adaptarlos y llevarlos esto a una práctica clínica diaria y segura para los pacientes, siempre con un beneficio hacia ellos. Y esto probablemente lleve un tiempo y parecen cosas un poco de ciencia ficción, y verdaderamente todas las imágenes que mostró Peter en su presentación tenían un poco esta impresión, ¿no? De ser todas diapositivas del futuro, en el cual estamos viendo situaciones de quirófanos que desconocemos al día de hoy, pero que probablemente estén orientados hacia lo que ya está ocurriendo en muchos de estos lugares como Alemania, y acabamos de ver. Una fotografía impactante que mostró Patrick en su presentación y me sorprendió fue cómo en uno de los slides donde mostraba uno de los problemas en el cual el robot con sus cámaras ocupa un lugar importante en el campo del cirujano para poder actuar, y esto simbólicamente creo que nos debe generar la reflexión de que de alguna manera están invadiendo nuestro espacio en el quirófano necesariamente para tratar de posicionarse en una situación en la cual ahora el robot necesita ver para poder mostrarnos cosas, pero lo interesante y el concepto tiene que ser que hay que darle ese espacio porque el robot necesita ver sitios y lugares mejor de los que el ojo humano puede ver como cirujano. Y yo creo que esa mirada, por eso esa foto enseguida me generó esa imagen en cómo ahora está molestando el robot, pero no, en realidad está tratando de mostrarles eso y situaciones con mejor resolución y con mejor angulación de lo que podría darnos la visión con el ojo humano. Entonces hay que ceder ese espacio y estar propenso a generar en el quirófano un ambiente compartido en pos de mejorar el acceso. Y evidentemente con la presentación de Diana, en la cual vemos que ya no solo es muy importante contar con el registro de microfónicas cocleares, con registros eléctricos durante ciertos pasos del procedimiento quirúrgico en la cirugía de implante, sino que hay que ponerlos en simultáneo, de alguna manera solapados a lo que el cirujano está viendo, y acá había algún discernimiento en cuanto a cómo hacer ese feedback. En primer lugar era la audióloga o el electrofisiólogo que podía generar alguna situación de alarma hacia el cirujano para que modifique su tiempo de inserción. Eventualmente se podía disponer de alguna alarma sonora para que indique información en relación a los potenciales intracocleares durante la inserción, pero una manera muy interesante y muy bien lograda con la tecnología, cuál es la superposición de imágenes para el cirujano en el mismo tiempo de la inserción y poder el cirujano adaptar o modificar o pausar o hacer gestos durante la inserción que de alguna manera modifican la respuesta instantánea electrocopiográfica en este caso, es muy interesante y eso sin ningún lugar a duda, en nuestra opinión, va a permitir resultados mejores en los beneficios auditivos del paciente, porque si dañamos menos la cóclea durante la inserción y preservamos estructuras, desde ya que la situación para la cóclea va a ser mejor y para el beneficio auditivo del paciente va a ser mejor. Así que realmente muy valiosa la contribución y cómo eso además, y esta es otra cosa importante y otra reflexión, debe ser medido en distintos aspectos y parámetros que modifican la cirugía. Y ustedes vean que en alguno de los slides que mostró Diana, en su trabajo preliminar, más que tener en cuenta con los resultados de preservación auditiva, con el uso de esta técnica, los primeros indicadores deben ser aquellos que indiquen cómo se modifican pasos de la cirugía en pos de esta tecnología. Y la primera muestra es que verdaderamente el tiempo de inserción pasaba de aproximadamente 40 o 50 segundos a 200 segundos, cuando el cirujano cuenta con información de feedback dinámico durante la inserción. Evidentemente estábamos insertando a ciegas y sin preocuparnos, solamente pensando qué es lo que podía ocurrir dentro de la cóclea, sin ninguna posibilidad de cambiar o modificar nuestros gestos. Y el hecho de contar ahora con el feedback e información de modo simultáneo y solapado con el tiempo quirúrgico, prolonga la inserción, porque eso implica que estamos siendo más cautelosos y que estamos modificando y mejorando nuestra técnica. Seguramente aquí también la inserción robótica jugará un papel valiéndose de esta retroalimentación de feedback para poder mejorar y corregir la cirugía. No sé si hay alguna otra pregunta o algún comentario. Estamos dispuestos a que si quieren escribir alguna cosa en el chat y si no, atento a algún comentario o alguna...
Hay dos manos levantadas. Yo no sé si quieren hablar. Incluso podemos abrir los micrófonos.
Sí, ningún problema. Pero tú que estás como organizadora lo puedes ver y yo no tenía ningún problema y estaría gustoso de poder compartir con algún colega que quiera hacer algún comentario. Bien.
Sí, por favor. No. No, I think. Okay, yes. I think there is, yes, we have Marta. I will talk in English. Marta Isabel Rossetti, Luz. ¿Puedes abrir el micrófono de Marta y Carlos? No sé si quieren hacer preguntas, pero abrimos sus micrófonos.
El micrófono está disponible, tendría Marta que activarlo manualmente.
Marta o Carlos, si está con la mano levantada, pueden activar sus micrófonos manualmente si quieren hacer alguna pregunta, porque si no vamos al cierre. ¿No? ¿Algo más? Más 3 minuticos y ya voy a compartir mi pantalla de cierre. Si alguien quiere abrir. Bueno, entonces yo creo que de verdad terminamos acá. Thank you so much for Dr. Arlier, Dr. Schule, Dr. Dilela, and for us it's a pleasure to have you with us. And thank you so much for Luz Adriana. She's our backup to make this event possible, and Horst and Peter Gibson and Valeria Ojanguren. So this is our staff that works together to become this event possible. Thank you so much, and we finish our event now. Federico, I'm not sure if you want to talk something.
Yes, well, finally, I would like to thank you very much, the collaboration and the kindness of Diana and also Patrick, and thank you for sharing your new approach, and the opportunity to have this in Latin America is a privilege. So just keep in touch. We are working hardly with cochlear microphonic also and some impedance, and we believe that this would be the next step in CI surgery. So hopefully we'll see you present in the future in our meeting. So thank you so much.
Thank you so much as well.
Thank you so much. Please come and visit us in Germany sometime.
Yeah, that would be a good idea.
It will be a pleasure.
It's only 500 kilometers from Essen to Ulm. You will manage. It's no problem.
Wow, no, it's not impossible, and it will be a pleasure to see this technology personally is like a future near from us. So thank you so much again and again, and this is. Gracias por la audiencia, gracias a todos que estuvieron conozco todo este tiempo. Tenemos previsto el próximo para octubre y será de inteligencia artificial aplicada a la ay, me fue la palabra.
Calibraciones remotas.
A las calibraciones de los implantes, ¿sí? Que tengan un buen día. Have a nice day. Bye.
Bye-bye.
Goodbye.
Bye.
Goodbye. Have a nice weekend.